Hello. So this is the second lecture on vectors, and in this lecture we are going to discuss cross product of vectors. Okay. So let's start. Cross product of vectors. Suppose there are two vectors. Let's say A vector and B vector. Okay. So if we will do the cross of these two vectors, we can use right hand thumb rule. So there are two possible directions. It might be this direction, it might be this direction. This direction will get A cross B vector, or we can get here also A cross B vector. Okay, since it is a vector, so it will have a direction. And A cross B, there in dot product, the quantity which we got, that was a scalar quantity. Here we will get a vector quantity, so it will have a direction also. Now let's say this is a C vector. So now this C vector will be perpendicular to both A vector and perpendicular to B vector. Both conditions must be satisfied. That this third vector, that is a C vector, it must be perpendicular to A vector also, and it must be perpendicular to B vector also. Then we can say C vector is A cross B. More we can say, in a correct way we can say it as a lambda A cross B vector, where lambda is any scalar value. Okay. Now what is the mathematical formulation of A cross B? So A cross B is actually magnitude of A into magnitude of B into sine theta, where theta is the angle between A and B vector, okay, and into n cap. This n cap is the unit vector, as we saw that there are two direction possible. Since two direction are possible, so that n cap will show the unit direction of that vector. That is its role, that is unit vector. It is a unit vector, so it will show the direction. And this will be the magnitude of the resultant vector, which we will get after just doing A cross B. This is magnitude of A cross B, and this will represent its direction. Okay, so A cross B like this. This is angle theta, and this is a C vector, which is A cross B. Right? So this is the formulation of A cross B. And most of the time we write A cross B like this. Okay. So it is this. This is the magnitude of A cross B. Okay. Now, so there is one case, that is unit vector perpendicular to both A and B vector. Okay, so this will be A cross B over magnitude of A cross B plus minus. This plus minus shows the direction of that particular vector. Two directions are possible. We take this direction as positive, this direction will automatically be negative as per the vector rules. This will be the unit vector perpendicular to A cross B. But if we are required to just find the vector which is perpendicular to both A cross B, then this will be the answer. That is uh, what you say. Let me tell you in the next slide. So if it is said that we are need to find a vector which is perpendicular to both A and B vector, so we will write it as lambda times A cross B. This lambda is a scalar value. It can be 1, 2, any scalar value it can take. Okay. If we assume lambda as 1, then we can write it as A cross B, but more mathematically, more in a more correct way, lambda should be written. Okay. Now in the previous lecture I missed one part. Okay. So I want to cover this here. That is this concept which we say there are two vectors A and B vector. Sum of these two vectors, then we have to find its magnitude, and then we have to square it. This forms a formula similar to the A plus B whole square formula, but little different. because there we write 2ab, here we will write 2a dot b. Why? Just uh, simplify it, you will understand what it is. Here you are multiplying both. We will use dot a dot b plus mod b square mod a square plus a dot b. From here you can write this. Again we can make one more formula for our simplified calculations, that is a plus b plus c whole square, which is similar to this, mod a square mod b square mod c square plus 2 times not ab bc ca but a dot b b dot c c dot a. Okay, this you must know. These are the properties of, or you can say uses of dot and cross product, which I am covering in this lecture, because in this lecture we are winding up the dot and cross product. Next lecture we'll discuss scalar triple product. Now you must know a dot b. If you are writing, it is equals to b dot a dot lambda b. It can be written as lambda a dot b like this, or you can write in this way. Okay, these all three are possible. Talking about uh, what do you say, a cross b. So a cross b is not equal to b cross a in the absolute terms, but in the magnitude, the terms of magnitude, they are equal. Since direction is a vector, so directions are different. So we write a cross b is equals to minus of b cross a. Okay, and this multiplication can be done as we did here. Okay, so like this. Uh, yeah, and here we go. Okay, I hope you got this also. And next important thing is, just slipped out my mind. We discussed dot product, cross product. So one more thing, two more things, like ijk, which we have discussed in dot product. Just make it a cycle, and now you write I cross. Since these are perpendicular vector and we are making it cross, so sine theta will not be 0. So hence I cross j will be k, j cross k will be I, and k cross I will be j. Okay. So ijk and jki and kij. Okay. But if you will just reverse it, j cross I, it will be minus k. As we discussed earlier, we will make it k cross j, then it will be minus I. If we will make it k cross I, say I cross k, then that will be minus j. Okay. So I think this is clear to you. Now talking about application of cross product of vectors. Last topic of today's class, cross product. So it is used in finding the areas. Like just take these two, a vector and b vector are the co-initial vector, or it can be co-terminus vector. Co-initial, which start with the same initial point. Co-terminus, which ends at same point, like this. Here we say these are two co-terminus vector. These are two co-initial. Okay. So if two co-initial vectors are given, and we are required to find area of the area of actually the parallelogram which is been created here, that will be magnitude of a cross b. Same area of triangle will be half of a cross b. As you know, parallelogram is made up of two, say, triangles only. So in that way you can see, or you can see in this way also, these two are a cross b vector, and here we go with the third one also. Okay, so half of out of a cross b. But suppose this is a parallelogram and these two vectors are given to, that are diagonal vectors d1 and d2. Diagonal vectors. So for diagonal vectors, area will be half of mod of d1 cross d2. There it was half of mod a cross b, that is for triangles. For parallelogram, it was as we studied base into height, so we can relate it as a cross b. Now for diagonal, it is half of mod of d1 cross d2. Clear? Now talking about yeah, this formula. This formula can also be used in finding area of, this was parallelogram, but we can use it in finding of area of quadrilateral also, where d1 d2 will be the diagonal vector. Yeah, this is also the formula to find the area of quadrilateral. This is rare, it is very rare, but these are important. That first you have to understand the area of parallelogram. If a and b are co-initial or coterminous vector, that is mod of a cross b. For triangle, it is half of mod of a cross b, as we related with half into base into height, and for diagonal it is half of mod of d1 cross d2. This was the cross product of vector. We have also discussed the properties of dot and cross and application of cross product of vectors. Okay, and in next session we will discuss a scalar triple vector triple product and related concepts. Okay, and properties. Vector triple product will do very basic. Scalar triple product little more detailed comparatively. Okay, I hope you understood everything, and thank you for joining me in this session. Next session we'll discuss scalar triple product and vector triple product. Thanks so much.